Hey guys, welcome to AKV and this is Vishnu. So this illustration, Shylock Airways is planning to acquire a light commercial aircraft for flying class clients at an investment of 50 lakh. The expected cash flow after tax for the next 3 years is as following. So it will be the cash inflow. So years and probabilities has been here given year and cash inflow, that is cash flow after tax and probability. So year 1 14 lakh, 18 lakh, 25 lakhs and 40 lakhs, probability 0.1, 0.2, 0.4 and zero point 0.3. Year 2 CFAT, that is cash flow after tax 15 lakh, 20 lakh, 32 lakh, 45 lakh, probability 0.1, 0.3, 0.4 and zero point 0.2. Then year 3 cash flow after tax 18 lakh, 25 lakh, 35 lakh and 48 lakh. The probabilities 0.2, 0.5, 0.2, 0.1. The company wishes to take into consideration all possible risk factors relating to an airline operations. The company wants to know: number 1, the expected NPV of ventures, assuring independent probabilities distribution with 8% risk-free rate of return. The possible deviations in the expected value, and third one, state the importance of standard deviation of the present value distribution in capital budgeting decision. So going ahead with the solution, first year 1 and year 2 and year 3 cash flow after tax and probability has been directly taken from the question, and we will take the sum, the multiplication, that is cash flow multiplied by the probability of 3 years, and when we take the total we will get 27 lakh for the first year and 29 lakh 30,000 for the second year and 27 lakh 90,000 for the third year. After taking the expected value, you need to multiply it with the discounting factor of 8%. That is, for the first year it will be 1 divided by 1.08 will give you 0.92598, and 0.9 for second year it will be 0.92598 divided by 1.08 will give you 0.8573. In the same way, in the third year 0.8573 divided by 1.08 will give you 7983. So when we multiply it, so the expected value should be multiplied with the present value, you will get the total value, which is 72,25,795 less cash outflow. So the cash outflow is 50 lakh, that is mentioned in the question, that is the price of the aircraft. So the net present value will be 22,25,795. Now possible deviation in expected value will be, so for the first year it will be, the expected value will be 0.27, that is 27 lakh minus x factors. So the x factors will be 14 lakh, 18 lakh, 25 lakh and 40 lakh. So x minus x bar will be 14 lakh minus 27 lakh and 18 lakh minus 27 lakh, and 25 lakh minus 27 lakh. So we'll get the figures as negative 13, negative 9, negative 2, and 13. And next one is, we should be x minus x dash the whole square. So the x minus x dash has been already found out in the previous column, and so when we multiply it or square it, which is 30 into 30 will give you 169, 9 into 9 will give you 81, 2 into 2 is 4, 13 into 13 will give you 169. So after computing the x minus x dash whole square, it should be multiplied with the probability factor of the respective year. We will get the sum total of x minus x dash the whole square multiplied by the p will give you 85.4. So when we take the root of 85.4, we will get the standard deviation as 9.21, which is the risk of the first year. Next one, in the same way, you need to compute it. The expected value is 29.3, which is so 29x is the CFAT of the year 2 minus 29.3 will give you x minus x dash, which is 14.3, 9.3, and 2.7 and 15.7. We need to take the square and multiply it with the probability. You will get the total as 98.61. When we take root of 98.61, we will get the standard deviation as 9.92. The same way, you need to take the probability or the standard deviation of the third year, which is square root of 74.29, as the answer is 8.169. So the standard deviation is a statistical measures of dispersion. It measures the deviation from the central number, that is the mean. So in the context of capital budgeting, the decision, especially where we take up two or more projects given somewhere similar, means cash inflow by calculating the standard deviation. In such cases, we can measure in each case the extent of variation. It can then be used to identify which of the project is riskier in terms of variable of cash inflow. A project which has a lower coefficient of variation will be preferred if size are heterogeneous. Besides this, if we assume that the probability distribution is approximately normal, we are able to calculate the possible probability of the capital budgeting project generating a net present value less than or more than a specific amount. So guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe.